Hello everyone. So my topic for project is design and simulation for parallel HEV powertrain with torque and speed coupling. So I'll be presenting it now. So the basic contents of my project uh, are like what are actually what are hybrid electric vehicles and what are I've taken Toyota Prius as my reference to my project. So I'll be presenting what are the Toyota Prius specification and the architecture that I have used that I have obtained from autonomy, then the design parameters that I have used to like simulate the EDTS and SWFET cycle, and how I've simulated in the autonomy, and the graphs that I've obtained from torque and speed coupling, and some results and then conclusion. So hybrid electric vehicle is HEV is a type of hybrid vehicle that combines internal combustion with electric propulsion to increase the fuel economy and decrease the fuel emissions, harmful emissions like CO2 and carbon monoxide, etc. And Toyota Motor Company is like leading in production of hybrid vehicles as of January 2007. So I have used Toyota Prius as my reference to my project, and its specifications are like it has two motors. The motor one has a power of 115 kilowatt, and motor 2 has power of 53 kilowatt, and engine power is 71 kilowatt, and combined output power would be 54 kilowatt, and it has a torque of 163 Newton meter. So actually Toyota Prius, I've used a Toyota Prius MY10 model as my reference. This is the architecture available for split HEV in autonomy that I have used as my as to design my vehicle. And these are the design parameters that I have used in this architecture. So the total vehicle mass would be 1125 kgs, and I've taken driver mass as an average of 75 kgs, and wheel radius is 0.22 meter, sorry, uh, and coefficient of drag is 0.2 approximately, and density of air is 1.16 kilogram per meter cube, and it takes 0 to it goes 0 to 100 in 10.7 seconds. So these are it is the comparison between the existing Toyota Prius model and my new design. So Prius has engine power of 71 kilowatt, and my new design has I've inputted my power as 80 kilowatt, and Prius has motor power of 53 kilowatt, and I've inputted the motor power as 57 kilowatt, and Prius's fuel economy is 54 for city and 50 for highway. It is in miles per gallon, and the fuel economy that I have obtained from my simulation is like 57 for city and 56 for highway. Like I've taken the parameters very close to the Prius's existing Prius's model, because I wanted to like get near fuel economy to the prices model. In future I'll be changing the parameters rapidly, and I'll see what how how fuel economy varies because of those. So these are my results that I have obtained from simulation in autonomy. So I have obtained the fuel economy of 57.75 for EDDS and 56.57 for highway, and CO2 emissions is like 78 gallon per kilometer per ton for UDDS and 79 for highway, and these are the graphs that I've obtained for battery, engine, and motor output. On the left side, it says it is prices, like prices graphs, and on the right side, it's my new designs graphs, and these are the motor torque and power graphs. As you can see, on the above are the graphs for the prices model, and below are graphs for my model. As you can see, since I've taken the parameters very near to the prices model, it is basically it has basically similar torque and power graphs. So in conclusion, like, I have modeled an split HEV in autonomy to increase the fuel economy and to decrease the harmful emissions like CO2, etc. And I've simulated the both vehicle in autonomy for UDDS and HWFET drive cycles, so that I can compare those results and see how it varies. And it has demonstrated improvement in fuel economy and decrease emissions. So in future, I'd be changing more parameters, like increasing, not near to the prices model, but increase the parameters more and see what happens to the fuel economy and CO2 emissions. So thank you.